What's now going to happen as all that CO2 starts to dissolve into the ocean? What changes are we gonna see? Does anybody off the top of their head want to make some hypotheses? What's going to happen when all this CO2 goes into the ocean?
pH level, the acid level goes higher.
Cool. Great. So we've studied this before. What we're going to do is we're going to use some very simple materials, and we're going to give you guys all these materials so you can bring them back to your classroom. One is an indicator called bromothymol blue. All right, and non-toxic, real simple indicator. And what does it do? Yeah. Yeah, it's a pH. It indicates the pH. Okay. So in this bottle, I think we have just plain old water. And so we're going to just do this as a demonstration, but with your students, this is a great way to introduce a laboratory activity, procedures, the materials, doing a laboratory write-up. And so for the materials we're giving you, we've written it up like a formal lab, more like an inquiry lab, making a hypothesis, what's going to happen. For our purposes, we're just going to quickly go through it because it's very simple. Do you mind holding our plain old water? And our hypothesis of what's going to happen when we put the indicator, what's going to happen to this water?
It's going to turn blue.
It's going to turn blue. We're going to stir it up. Ah, it is blue. And this indicator turns blue when things are not acids. Anything that's not an acid. You can just hold this. The next substance we have is household vinegar. Sorry, we're not going to give you vinegar, but we believe that you could maybe find this plain old household white vinegar. To start this out with your students, we like to do a little exploration about what is an acid. What makes something an acid? Depending on the level of your students, 7th, 8th grade, 9th grade, we're going to be talking more about pH. We're going to be talking about the pH scale, possibly even hydrogen ions, what that means to be an acid. For younger students, I've done this with 4th graders, and just talked about things that, what do they think of when they hear the word acid? What is acidic? And what are some things that your younger students might say that's acidic?
Lemons.
Like lemons or orange juice. And so maybe we can get some of these substances and test these substances. What are they? For vinegar is great because vinegar is a simple acid. And what's going to happen when we add the bromothymol blue to it? It's going to change. It's not going to be blue. It's going to be some other color. Pretty sure it's going to be yellow. Yeah. So when it's an acid, it turns. And when it's not an acid, it is? Okay, so this is where you get your nice, brave students, and you give some simple instructions. Probably the only safety thing is that students associate straws with sucking, but we're going to use straws only for exhaling, for blowing. So we can all practice. Everyone take a deep breath and let it out and go, ah. What do we breathe out? Yeah, CO2. Yeah, we also breathed out a little bit of oxygen because we don't use all of that we breathe in. We breathed out a lot of nitrogen, but yes, we breathed out some CO2. Okay? Depending on the level of your students, we can talk about the chemical process. What happens when CO2 interacts with water? What are some hypotheses? Somebody said before, Drew, somebody said before that, yeah, it's going to become acidic, that a carbon molecule is going to interact, CO2 molecule is going to interact with the H2O molecule, and it's going to make carbonic acid. Who would like to demo this?
Only exhalers.
Only exhalers. Brenda. Brenda's brave.
Brenda.
So Brenda, give us you can stand up here and blow some bubbles like you're blowing into chocolate milk. And you might get a little splash. It's non-toxic.
Good lung capacity.
There you go. So it's green, and if she kept going, and with students you can practice different materials and methods. With a stopwatch. 10 seconds. What happens after 25 seconds? But eventually, you know, we only can produce so much CO2, saturation of water. But yeah, we get yellow. And essentially, we also are going to give you a little sheet that is a chart that tells you the pH scale. Essentially, bromothymol blue is blue in pretty much all of the more basic we find with students, I like to describe this as just not acid. Okay, until they're learning about chemistry and hydroxyl and hydrogen ions, then we can use those descriptions. But for younger students, we can break it down to just acid and not acid. And it's blue when it's not an acid, and it's yellow when it's an acid. And Brenda almost got this to yellow. And we could even match this, and we could say, we are definitely on the acidic side of the pH scale. So she produced an acid by doing what? Just blowing CO2. And that's what's happening to our oceans. Our oceans are becoming more acidic. And this is something, there is absolutely no debate behind this. We can go out and take measurements of our ocean, and they have been. And NOAA has this huge monitoring project across the oceans, across the world, and we observed a marked increase in acidity. Okay? Now, we didn't do this, but this is definitely an extension. If we took a sample of ocean water and we put the indicator in it, what color would it turn? If we used ocean water. Amy was drinking tap water, so that was just tap water.
Salt water.
So salt water.
Acidic.
Is salt water acidic to start with? Is it neutral or is it basic? What do you guys think?
Salt.
Salt water. Ocean water.
Neutral.
Yeah, ocean water is actually, it's pretty basic. It's pretty basic. And it's basic because of all the minerals that are washing into the ocean. From all around the world for the past 4 billion years, there have been minerals washing into the ocean, making that ocean water pretty basic, about pH 8, a little higher than 8. Okay? So when the carbon dioxide dissolves in the ocean, it's actually making it less basic. It's making it more acidic. Is it making it an acid like vinegar?
No.
No, it's not making an acid like vinegar, nor will the oceans ever become an acid like vinegar. But it's going to make them more acidic, which has a huge impact on the animals and plants that live in the ocean. What we're going to do next is we are going to get a chance to actually experience what are these animals that live in the ocean. And we are going to go don our snorkel gear and we're going to go into the marine lab and we are going to see the animals that live in the intertidal zone, many of these animals that are affected by this process of ocean acidification.